Hello and howdy, my fellow mathletes. Root Beer here, looking at more of our 2011 open paper. We are on question number 4 in part A. In the figure, AQPB and ASRC are squares. AQS is an equilateral triangle, and QS is 4. So, I've already sort of mucked up my picture. So if it's an equilateral, all the side lengths are the same. And if these are square, all of those side lengths are the same. So I haven't finished the question, but I'm trying to fill in information. So what have we got? We've got BC is equal to X. What is the value of X? Okay. So that's kind of interesting. So let's draw a bigger picture. So we've got all these 4s here. We got this triangle down here. We know it's 4, 4, and X. Now, where can we go from here? Well, this triangle down here is sort of the key. It's a 4, 4, X triangle, and I'm fairly certain. So what do we need to finish this off? Well, if I knew this angle here. I also strongly suspect, because this is nice and symmetric, if we just sort of divide in the middle, we'll get the nice little right angle. This is isosceles after all. And I think it might be easier to work things out with right angle, maybe? I don't know. But we definitely need another piece of information. I'm not married to this right angle dividing things in the middle thing yet. But we definitely need another piece of information. We have 2 sides, we need the third side, but you can't figure out a triangle just from 2 pieces of information. We need one more. Where is it going to come from? Well, angles in here. Squares have an internal angle of 90 degrees, and an equilateral triangle has an internal angle of 60 degrees. And around this point should be 360 degrees. So what should be left over? 120 degrees. And 120 plus 60 is 180. 2 90s is another 180, and that gives me the full 360 degrees. Okay, so we have an angle of 120 in our triangle here. And actually, I think I'll draw the triangle a little bit bigger. I've got the space. Why not use it? And I think I will divide it evenly because it's going to give me 2 sort of equal triangles. Mirror images of each other, and that breaks this 120 degrees into 260 degrees. Okay, it also breaks the base into x over 2 and x over 2, so I still just need to figure out what x is. But now that I've got a nice right angle triangle with a 60 degrees, I might remember there's a very special 30, 60, 90 triangle whose side lengths have a very nice relationship. They have a ratio of 1 to root 3 to 2. So if you know one of the sides, you can figure out the others, and you don't have to go to trigonometry. Although if you were going to use trigonometry, angles, figuring out things like sine 30 degrees is not particularly difficult, and something that if you've encountered trigonometry, you certainly have seen that before. But okay, if my hypotenuse is 4, that's the 2. So the side length opposite the 60, 4 to x over 2 is the same as 2 to root 3. The side length opposite the 60 gives us the root 3. Another way to say this, if you're not familiar with ratios, would be something like x over 2 over 4 is the same as root 3 over 2. Well, great. Now we can... now I've run out of space. We'll move it up here. But that tells me x over 8 is the same as root 3 over 2. Multiplied by 8 on both sides, x is going to be 4 root 3. Just doubling that side there. And there we go. So I figured out the length of x is going to be 4 root 3. And there's not really a whole lot else to say. You didn't have to divide it like this. If you're more comfortable with trigonometry, you could use something like the cosine law, knowing that we had 4, 4, and a 120 between them. But I think 4 root 3 from the 30, 60, 90 triangle is a little faster and perhaps a little easier to understand. You might not be a master of trigonometry, but if you've done more math contests, you certainly know about the 30, 60, 90 triangle. Okay, that finishes off Part B of our contest. Sorry, not Part B, Part A. Now we're going to move into Part B of the contest with question B1. And we'll take a look at that in the next video. I would encourage you to try out Part B before watching the next part of this contest. But either way, I will see you in the next video for more math.